Yes, the title we agreed was technical legal reality of level 4 vehicles, autonomous vehicles, and I just put together some technical and other concerns which we need to deal with, and giving a short overview about those. Um, okay, so autonomous driving, yes, it's pretty hot topic, and uh, where we get there, it's actually changed quite a lot over the time. I just had yesterday conference in autonomous vehicles in Florida, and the one presentation started with that in 1975, there was some attempts to have autonomous vehicles, and they estimated at the end of the 70s or beginning of the 80s, there is already autonomous vehicles on the road, which seems pretty funny at the moment. And even a couple of years ago, Elon Musk announced basically that by the end of the year 2020, there will be level 5 autonomous vehicles available, because there's no fundamental challenges remain. But as you know, there's still we don't have these vehicles on the road, and they have to postpone all these promises. And not only Elon Musk, but also other big companies like Ford, GM, and others several times had to postpone their promises in autonomous vehicles. And that's something we have promised or hope to have, but reality may be rather something like this, that yes, there are autonomous driving functions. They work pretty well in standard environment, but there are many challenges, especially those small things are not enabling us to have a full autonomous driving. Little bit background about different levels of autonomous driving systems. So we have basically 6 levels defined by SAA, and level 4 is fully autonomous driving, but in limited operational design domain, which means that it's not available everywhere. It's available with limited conditions. And level 5, which is the fully autonomous driving in any conditions. So there is no that big functional difference, but rather difference where and what conditions this autonomous driving is available. And most of our current vehicles are level 1, level 2. And if you talk about personal cars. We don't have much level 3 vehicles, but we do have a level 4 vehicles. And that's exactly because this operational design domain enables us to limit all these conditions where this autonomous driving is engaged. And it can be limited in various different ways, starting from the graphical location. So we define the area like we had in our previous talks, raw area or whatever. So we can pre-map or make this area very well known for the vehicle. There is a road types, speed, very important issue specifically for the level 4 vehicles, that we are driving in a low speed. We don't drive, let's say, in highway speeds. So it's pretty different conditions and functional setup for the vehicle, which depends on the speed. Also weather conditions, day or night, traffic conditions, network conditions, and so on. So it means that if we limit our operational design domain with a specific parameters, then we can actually have quite, let's say, simplified way to bring the vehicle on the road. But of course, its limits also its functionality. And this level 4 vehicles are mostly AV shuttles, last mile or first mile shuttles, what exist in these most common forms like Navi and EasyMile, most well known, but also our Isauto developed here in TalTech. Also in Finland, there is a Sensible 4 vehicle, which is one prototype There are many others are coming specifically from China, from US. The big OEM companies are paying attention to these shuttle buses. So this is a classical level 4 autonomous vehicle without steering wheel, without brake or acceleration pedal. So there is no driver seat, but there's still manual driving option, which can be switched from the autonomous to the fully manual driving in case of need. So the technical issues or barriers, what we have, first I would bring out the sensors. The autonomous driving is relying on the sensing, like human driving as well. And you need to have pretty good sensing capabilities in order to make proper decisions. And the most common sensors for the vehicles are the radars, lidars, and cameras. Depending of the function of the vehicle, the sensor set can be also quite different. For example, the private cars like Tesla are relying mostly on the camera and radar. The L4 shuttles are relying mostly on the lidar and using cameras or GNSS for the corrections. But as you see in this table that every type of sensor have their strengths and weaknesses. For example, radars are good for the distance estimation, but they are not that good for the object classification. And also in the LiDAR are good for object detection, but not that good for tracking. And also they are not very good for high speeds in terms of frequency or speed of what they can handle the data collection. And they produce very huge amount of data, which needs high processing performance. And the cameras are more similar to the human eyes, have a poor weather performance, but on the other hand, good lane tracking and so on. So the answer is here the sensor fusion, but it gives another challenge that we have to have very good machine learning algorithms. And that's another barrier or technological issue at the moment, that machine learning algorithms are not yet widely accepted as a safe solution, because mostly of high performance computing need for the sensor fusion at one point, but also the lacking of contextual understanding. For example, in the image left, you can see the vehicle, which is nicely classified. But if there is an images on this vehicle, which we can see quite a lot in our daily traffic, the machine learning algorithm detecting these as a bicyclist or persons, even they are just the pictures. And if we make decisions based on this classification and thinking that we have a bunch of bicyclists in front of us, of course, the decision-making process is not correct. So this neural network training is definitely the issue. And also if you talk about other problems like direct sunlight, again, it's very, very hard to make good decisions. The technical issue about edge cases. So there can be good algorithms for the standard driving options. But as we know that rare situations or just can happen on the road, like animals jumping on the road, or there is some construction going on. So again, in the human perspective, the common sense reasoning helps us to solve these problems. But for the machine algorithms, it's not that easy. There is no training data, and we can't just train everything, all possible solutions. So it makes difficult actually to make reasonable decisions in these edge cases. What about regulations? So that's also the barrier, of course. And it's not only that we have one lacking of autonomous driving law or something like this. First of all, the safety is the biggest concern, and there are different safety standards, but there is no direct safety standard for autonomous vehicles. there are many laws actually, or legal acts connected to the autonomous vehicles, like vehicle registration law, passenger transport law, also the vehicle operator requirements. For example, if you talk about teleoperation, then this teleoperator must have a proper category driving license. So if you talk about the passenger transport, then we can imagine that the teleoperator needs to have a proper category, but maybe these people who have this category are not that good of computer gaming. So which is teleoperation is more similar than just operating the full-scale vehicle. Also data protection laws, liability laws, and so on. So in one project, TalTech has completed this Social Baltic, has quite a good overview of legal situations a couple of years ago. So it's the area is actually coming very fast at the moment, specifically this year. It's in EU regulations currently going on about the type approval for the motor vehicles regard of autonomous driving systems, and the initial scope is robot taxis and shuttles. Also in Germany, there is a traffic law changed already for the L4 autonomous driving, but there are implementing acts not yet approved. There's in France different things going on this year, and also in the Netherlands. And also in Estonia, sorry, this slide is in Estonian, but at the moment, working group consisting of industrial partners, ministries, the transport department is actively working with Estonian legislation in order to make changes in traffic law and technical requirements for the automated driving systems. And there is two approaches. First is for the teleoperation, the technical requirements, and another is requirements for autonomous driving systems. So there is a working group going together in every month at the moment, and also universities are involved. So there is also social acceptance, of course, like Tago already explained what our local research resulted in. I was just wondering, it's very close to the US survey, which I have presented here. Also the 15% saying that they never use autonomous vehicle. They don't believe it's going to be in the market, and quite a big amount of people say that they would never use it. And also the people, majority of the people demanding 100% of safety before they would take a ride. So it's actually a very big barrier. We need to train people. We need to familiarize the technology during the pilots, what we are doing already, so that people start trusting. And it's not easy. I don't know how many have experience of driving the fully autonomous vehicle, but I can say that first time can be quite scary because you have no control whatsoever for making decisions, and you don't know where the vehicle is turning. Specifically if it's public transport and you are not maybe that familiar of the specific road or every turn. Ethics again comes in, so it's not that simple anymore, and that's the very common question what journalists are mostly asking. Okay, what's the autonomous vehicle, how it decides, kill one or kill 10 of people if there is a this kind of decision needs to be made, or do you save the passenger or do you save the pedestrian? Do you save old or a young person, and so on? It's actually different in the cultures, like in Asia, Europe, and also in age groups. So it's actually very, very serious issue. It also comes to the privacy. Now we need to consider more and more, because these vehicles are going to be a connected vehicle. And of course, tracking, location tracking, sensor data, those vehicles are equipped cameras, lidars, which can be, and they are storing videos, also stream videos when they're driving around. So all these kind of concerns are coming into place. And of course, the cybersecurity issues. For example, our vehicle is connected to the traffic lights. Teleoperation is a very big concern. If someone can take over the autonomous vehicle remotely and make harm or having bad things in mind. So it can be very dangerous. So it has to be dealt quite a lot. And yeah, for the conclusion, what we are working on, what's important also is the simulation and the validation. If we want to bring the vehicles on the road, we have to put much more attention to the simulations in the virtual environment before we go to the road. If you compare it with the standard cars, which needs mostly in technical validation and testing, but here we need to simulate and validate the autonomous driving decision-making process, which is much more complicated. It also brings the issue that if there is a software updates, so how can we sure that the software update is improving the system, not maybe making some things worse that have happened. For example, in mobile phones, you know that maybe update will drain more battery than the old version, but this kind of safety critical issue can also be problems with the software that's will be anyway updated quite frequently in autonomous vehicles in the future. And there are different concerns, but I think my time is up. So yeah, here is just the topics what we are working in autonomous vehicles research group at TalTech, and of course doing in collaboration with Aalto. So thank you, and I give the floor back to.
Thank you, Raivo.